Okay, welcome back to another related rate question, and if you find my videos to be helpful, please leave a comment and let me know. Anyway, here we have this question. It says a water tank has the shape of an inverted, and this just means upside down, inverted circular cone. And we know that the base radius is 2 meters and the height is 4 meters. And right here it says if water is being pumped into the tank at a rate of 2 meter cube per minute, we would like to know the rate at which the water level is rising when the water is 3 meters deep. Okay, so as always, I will draw two pictures for you guys for the related rate questions. We will be drawing the water tank first, of course, and this is the cone. And first, you have to know that the radius of the cone is 2, and then the height right here is 4. And the water is being pumped in, and water should be in blue, so I will put down in blue. So like this, water will put down H2O if you're more of a chemistry person. Anyway, when you put in water, we are going to keep track of how much water we have in the tank. So let's say we have this part right here. And as time goes on, we know that the tank will actually stay the same, right? The tank is not going to get any bigger nor smaller. So let me try to see. They are the same size. I still have 2 and I still have 4, of course. But when we have more and more water goes in, we know that this part is going to be more and more, right? Higher and higher. So I'll just put down this right here for you guys, like that. So the blue part is the part that we want to focus on. Well, what are changing? It's first the radius of this cone formed by water. So I'll just call this the water cone. And then we also have the height of the water cone. Right? This right here are changing, and be sure you label them with variable. The things that are not changing, the constants right here, you can just put that down as numbers. Anyway, this is what we have. And now let's go back to the question and grab information. Well, we used the 2 and 4 right here already, so that's pretty much it. But it says the water is being pumped into the tank at a rate of 2 meter cube per minute. So here, let's write this down. This is telling us how much water is going to the tank. That's the volume. So I'll put down dV because it says we have the rate. dV dt is 2. And we are trying to find the rate at which the water level is rising. So let me just put this right here. And that's this part, that's the h, right? That's the height of the water. So what we want is dh dt, right? And it says when the water is 3 meters deep or 3 meters high. So that means we want this part right here. So I'll just put down at the instant that h is equal to 3, right? Remember, this 4 in black, it's the whole thing. And we are looking for the part in blue, like that. Okay, for the related rate questions, we have to know a lot of geometry, especially the formulas for areas, volume, triangles, whatever, right? Here, we are talking about cone, and we're talking about how much water we have in the cone. Therefore, we have to use the volume formula, and I'll put this down right here for you guys. The volume of a cone is given by the formula 1/3 pi r squared times h. And in this video, I will just use the formula. Maybe later on I will explain why this is the formula for the volume of the cone, but that's later on. Anyway, let's identify what are the things that are changing. The volume of the water cone is of course changing. It's getting more and more water inside, right? And also the radius of the water cone. Originally it was like this, but it's going to get longer right here. So this is also changing. Lastly, h for the water cone, originally it was only this high, but now it's going to be this high. So this is also changing. Notice we have 1, 2, 3. We have 3 functions of time. That's not that good. But it's okay because this is what we can do. We can reduce one of the variables right here by looking at this picture again. Well, if you look back to here, this portion that we can see on the side, right here, right, this triangle, I'll put this down in black like this. We know that the top right here is 2, right? The base area right here is 2, and then the height right here, the whole thing is 4. And if you look at the water cone, we have this much only. This right here we labeled it to be R. This right here we labeled it to be H. Notice these two triangles are similar, so we can use a similar triangle, right? We can just like isolate, we can solve for one of the variables. You can do whichever way that you would like. You can do this over that, it's equal to this over that. Or you can do this over that, it's equal to this over that. Up to you. Let me just do this shorter side to the longer side in the triangle in black right here. That's equal to the shortest side to this side of blue, like that. And then we'll solve this real quick. That's just, see, this is 1/2. That's equal to R over H. And let's multiply both sides by H. We see that R is equal to 1/2 H. And that's pretty much it. And now let me plug this back to here, and then you will see we don't need to deal with R in this equation anymore. That's good. I hope R doesn't feel left out, but you know, it's okay in this video. Anyway, right here, volume, and I'll just put on V, okay, because we are talking about the cone already. Here we have 1/3. Pi is still pi, but R, as we saw, it's just half of H. So let's put down half H like this. And then square, and then lastly we have the H. And then from here, let's just work out some algebra right here. V is still V. Here we have 1/3 pi, 1/2 square is 1/4, and H square is just H square, and we have H. And notice, everybody here, they are just multiplying. And I would recommend you guys to do the following. When you have a fraction, multiply them first, and then put it as a fraction, as a coefficient, all the way in the front. What do I mean is, 1 times 1 is 1, over 3 times 4 is 12. So I will put down 1/12 like this, all the way in the front. And then we have the pi, and then we have H squared times H, that's just H cubed, just like that. And now we can work with this equation. We can just differentiate this with respect to time, and then the left hand side give us the v dt, and the right hand side, this is just 1/12. Pi is just pi, and I should actually bring this to the front, do the power rule. So this is technically 3/12, and then we have the H square, and then we have the dH dt, because H is also a function of time. Alright, so this is of course 1/4, and I need to find out what dH dt is. We know dV dt is 2, so I'll put down 2. This is just 1/4, and then pi is pi. H is 3, so let's put that down, and square that, and then dH dt, we don't know. And now let's just work this out real quick. 2 equals 2, this is just 9, times 1/4, we have 9/4. Let me put a pi on the top right here, because now you see this is multiplying with dH dt. We can just multiply both sides by 4/9 pi. That's multiplied by 4/9 pi right here, so that this cancel out, and then we get dH dt equals to 4 times 2 is 8, over 9 pi is just 9 pi, and then we are pretty much done. But we have to answer this question carefully. We have dH dt, and you see this is a positive number. That means the water is increasing, right? The water is rising. And the unit for H in our case is meters, right? We are measuring meters. So the unit right here will be meters per minute, right? So we'll put down meters per minute. And this right here, is it. Right? So hopefully this helps, and you guys should be doing more practice so you can get better at this. And that's it.